In this video, I have solved 4 problems based on formation of partial differential equations by eliminating arbitrary constant and arbitrary functions with a single variable and two variables. Hello students, in this video we'll learn about formation of partial differential equations by eliminating arbitrary constants and arbitrary functions. So let us take an example of formation of PDE by eliminating arbitrary constants. So here in this example, x minus a the whole square plus y minus b the whole square plus z square is equal to 4. It contains two arbitrary constants a and b. If the equation contains two arbitrary constants, the PDE will be of first order. So differentiate this partially with respect to x. So the x minus a the whole square derivative will be 2 into x minus a plus the derivative of y minus b is equal to 0. The z is a dependent variable on x. So therefore, the derivative of z square, we can write it as 2z dou z by dou x is equal to 0. Taking 2 common, it is x minus a plus z into dou z by dou x is equal to 0. So x minus a can be written as minus of z dou z by dou x. Similarly, if I differentiate x minus a the whole square plus y minus b the whole square plus z square equal to 4 partially with respect to y. So differentiating, so let me take this as 1, differentiating partially with respect to y. So the derivative of x minus a the whole square will be 0. The derivative of y minus b is 2 y minus b is plus the derivative of z square. So z is a function of y also. This derivative is 2z dou z by dou y is equal to 0. So from this equation we can write y minus b is minus of z dou z by dou y. So there are the standard notations for dou z by dou x. So the first order derivative dou z by dou x is written as p and dou z by dou y is written as q. Dou square z by dou x square is written as r. Dou square z by dou x dou y is written as s, and dou square z by dou y square is written as t. So we can also write this as minus zp, and here we can write this as zq. Substituting x minus a and y minus b values in the given differential equation, we have minus zp the whole square plus minus zq the whole square plus z square equal to 4. Squaring and taking z square common, it is z square p square plus q square plus 1 is equal to 4. So this is the partial differential equation for the given function. Now if the equation contains more than two arbitrary constants, if it is containing three arbitrary constants, the partial differential equation will be taken up to second order, and the PDE of that equation will have at least one second order derivative. Now we'll learn about how to form a partial differential equation which contains an arbitrary function. So here we have to form a PDE by eliminating arbitrary function. So note that it has a constants as well as it has the arbitrary function, but we have to eliminate the arbitrary function here. So when the equation contains only one arbitrary function, so the partial differential equation will have first order derivatives. So differentiating this partially with respect to x. So it is the derivative of ax is a plus the derivative of by is 0. C, the derivative of z, it is dou z by dou x, is equal to the derivative of the function f is f dash of x square plus y square plus z square into the derivative of x square plus y square plus z square with respect to x is 2x, y square is 0 and z square is 2z, dou z by dou x. So which we can write a plus c into p is equal to f dash x square plus y square plus z square. So taking 2 common, it is x plus z, dou z by dou x is written as p. Similarly, if I differentiate partially with respect to y, we will get b plus cq is equal to f dash x square plus y square plus z square. Here the differentiation is with respect to y, so therefore we'll get 2y plus zq. Now we need to eliminate that arbitrary function from the differentiation with respect to x and differentiation with respect to y. Now if we divide these two, it is a plus cp divided by b plus cq is equal to, always if it is containing one arbitrary function, go for dividing the partial derivatives, will get required PDE. This is divided by f dash of x square plus y square plus z square to y plus z into q. So these two get cancelled. Here the differential equation is a plus cp divided by b plus cq is equal to, even the two also get cancelled here, it is x plus zp divided by y plus zq y plus zq. On cross multiplying and simplifying, we'll get the partial differential equation as p into cy minus bz plus q into az minus cx is equal to bx minus ay. This is after cross multiplying and simplifying the terms, taking the coefficients of p, q and the constants on the right hand side. So here the point to be remembered is that if the equation contains one arbitrary function, then the partial differential equation will have first order partial derivatives. So there is one more variety of the problem. Here it is the function of one variable. Now suppose that if the function is of two variables, then how to form the PDE, that we'll see in the, here we have to form a partial differential equation by eliminating the arbitrary function f. The function f is of two variables. So let me take u is equal to x plus y plus z and v is equal to x square plus y square plus z square. So first find the partial derivatives with respect to x and y. It is the derivative of x is 1, y is 0 and the derivative of z is dou z by dou x, which we can write it as 1 plus p. Similarly, dou v by dou x is 2x plus 2z dou z by dou x, which we can write it as 2x plus z into p. Similarly, if we differentiate with respect to y, the derivatives will be 1 plus q and here the derivative of v is 2 into y plus z into q. So the dou z by dou y is denoted by a q. Now So the given function is something like f of u comma v is equal to 0. By using the chain rule and finding the derivatives with respect to x and y, we have by using chain rule dou f by dou u with respect to x plus dou f by dou y with respect to x is equal to 0, or else you can write dou f by dou u into dou u by dou x is equal to minus of dou f by dou y into dou y by dou x, which is dou f by dou u by dou x is 1 plus p is equal to minus of dou f by dou y, and y with respect to, here it is with respect to v with respect to x, it is 2 into x plus z p. Similarly, if we differentiate with respect to y, it will be dou f by dou u by dou y, dou x, dou u by dou y plus dou f by dou v with respect to is equal to 0. So we are writing the partial derivatives according to f is a function of u and v. U and v are the functions of x and y by the chain rule. So it is dou f by dou u and dou u by dou y is equal to minus of dou f by dou v into dou v by dou y. So dou f by dou u by dou y is 1 plus q is equal to minus of dou f by dou v with respect to y is 2 into y plus z into q. Now write this as equation number 1 and here this as equation number 2. If we divide 1 by 2, it will be dou f by dou u into 1 plus p divided by dou f by dou u 1 plus q is equal to minus of dou f by dou v into 2x plus 2z q. We have taken 2 common, so it will be 2x plus zp z into p. This is divided by dou f by dou v 2 into y plus z q. On simplifying, dou f by dou u, dou v get cancelled, 2 get cancelled. Even the minus sign also get cancelled. It is 1 plus p divided by 1 plus q is equal to x plus zp divided by y plus zq. On simplifying, we have the partial differential equation given by, on simplifying this, the partial differential equation taking the coefficients of p and q, it is y minus zp, z minus xq is equal to minus of y minus x, or it is x minus y. So this is the partial differential formation of the partial differential equation by eliminating arbitrary function with the two variables. We can have one more type of the partial differential equations where the two arbitrary functions we have to eliminate. Let us see one example on that. So here we have to form a PDE by eliminating f and g. So this is having two arbitrary functions. So your PDE will have at least one partial derivative of second order. So find the partial derivatives first. So dou z by dou x is p, which is the derivative of f is f dash of x plus at. The derivative of the x plus at with respect to x is 1 plus g dash of x minus at. The derivative is with respect to x is 1. Similarly, here the variable is t. So we'll take the differentiation with respect to t. It is f dash of x plus at. X plus at with respect to t is a. Similarly, it is g dash of x minus at into minus a. Find dou square z by dou x square, which will be differentiating dou z by dou x with respect to x again. So that will be f double dash x plus at plus g double dash x minus at. So find dou square z by dou x dou t, which will be dou by dou x of dou z by dou t. Here differentiating with respect to x for the partial derivative with respect to t. So that will be f double dash of x plus at into a as it is. So g double dash of x minus at minus a as it is. Go for finding dou square z by dou t square, which is dou square dou by dou z of dou t of dou z by dou t. So note that here there is a. So a constant. It is f double dash of x plus at. Derivative of x plus at with respect to t will be a plus g double dash. In the second term, minus a is a constant. G double dash x minus at. The derivative of x minus at with respect to t is minus a. So we have a into a is a square, and which you can take it as common. So f double dash of x plus at plus g double dash x minus at. Now we need to write a partial differential equation such that the PDE will have at least one second order derivative. We note that the equation 1 and 2 are related like dou square z by dou t square is equal to a square. This bracket is nothing but dou square z by dou x square. So here this is an independent of arbitrary function. So therefore this is the required partial differential equation. Thank you.